A critical analysis of triphasic training on improved RFD and performance athletes in power sports. I thought I'd take this opportunity to set out my objectives for the presentation. I'd like to briefly explain the triphasic training model before analysing a few aspects of it. I'll wrap up with a short conclusion of my findings. Diaz is a strength coach from the University of Minnesota who developed the idea of triphasic training in 2003. Passage from Cal Diaz and Ben Peterson's book recalls the exact moment the idea was born. It involved two similar athletes with very similar builds and lifts, but different rates of force development. One athlete out through the other, even though their maximal lifts were on par with one another. Following some force plate testing, Diaz found that one athlete was able to absorb more force eccentrically at a higher velocity. This in turn led to greater energy storage through the stretch reflex and stretch shortening cycle. Following this, a more powerful concentric contraction. In practical terms, one athlete was able to store more energy during the wind-up and apply more force in the shot, leading to a greater throw. This concept is referred to Cal as the V. It represents the ability to produce more force in less time. The goal of triphasic training is to teach athletes how to absorb more force eccentrically and isometrically before applying it concentrically. In other words, narrowing that V. Triphasic training is a method that focuses on eccentric, isometric and concentric components of movements or muscle contractions. Qualitative high-intensity work is the bedrock of this method. The body adapts under stress to stimuluses, and Diaz's model looks to increase stresses within each session to force a desired adaptation through an undulated block periodization model. What triphasic training allows us to do is to systemize these elements into coherent training approaches. Training usually consists of eccentric tempo-based lifting for 2 to 3 weeks, followed by isometric tempos 2 to 3 weeks, and concentric tempos for 2 to 3 weeks. Loading percentages for tempo-based work is usually greater than 80% for the conventional method and 105 for the supramaximal method. While the accumulation stage improves the building blocks of a movement, they're applied to sport-specific means for the first time during the transmutation phase. In this training stage, maximum power output is the ultimate goal. Power is increased by completing high velocity repetitions with slightly lower loads, ranging from 55 to 80%. The realization phase takes sport-specific training a step further by maximizing transfer of skill. It utilizes high velocity peaking methods, which call for an athlete to lift at less than 55% of their 1 rep max, using lighter weights as a maximal velocity, which continues to increase power outputs and the rate of force development. As power is a key determinant in the performance of many sports, optimizing an athlete's explosiveness for greater importance. Research has identified that RFD has been directly linked to performance during jumping, weightlifting, cycling, and even during a golf swing, suggesting better RFD can lead to a better athletic performance. Moreover, elite sprinters have been shown to possess greater RFD than well-trained sprinters. Collectively, this information suggests that RFD may be an important contributor to athletic performance. Improvements in RFD are likely to be a result of increased muscle tendon stiffness, enhanced muscle force production via changes in fiber type, and increase in neural drive during the early phases of SSC. In contrast, RFD appears to negatively affect by changes in muscle fiber from 2X to 2A and increases in fascicle length which cause reduced muscle stiffness. The program requires delivery of a large amount of stress for adaptation that can be in the form of high volume, high intensity, frequency, or a combination of all. A coach would need to be would need strict evaluation and monitoring of athletes to aid in continual development, especially due to the continued stress that's applied throughout the program cycle. The program is appropriate when the focus of the training is to develop specifically the RFD rather than the general strength or mass of an athlete. Diaz claims that the model is suitable for all sports. However, I believe it would require some careful management to cater for like a regular competing team sport like football or hockey or such. The key focus for the athlete must always remain on speed of the movement in order to develop RFD to the highest potential. Diaz and Patterson reported the program is best suited for highly trained athletes, but there's no suggested prerequisite to what they mean by highly trained. So during Sanka study in 2020, athletes were subjected to an 8-week program, including tapering. The study failed to outline the specific training plan, and we can make the assumption that if the athletes only trained for 8 weeks, there would not have been an opportunity to athletes to go through the transmutation and realization phase of the triphasic model. This is likely to have limited his findings and potential adaptations available to the athlete. Results of this study showed there was a significant difference following triphasic training and found improvements in both athletes' RFD and the individual sporting performance. The explosive strength test was drawn from a vertical jump, which provides some strong validity for us. However, the performance improvement factors was a subjective rating, which can be considered a further flaw in this study. An athlete, an important component of success in team sports is a player's ability to produce force, often in the form of acceleration. The player that is the quickest to the ball or the fastest off the line will often beat their opponent, giving him a sporting advantage of some sort. However, in later research by Diaz, it was identified that RFD is a good prediction for an athlete's velocity and acceleration on the field. During a study conducted with 48 ice hockey athletes split from Division 1 and Division 3, it was noted that there was a high level of correlation between on ice and off ice testing. The study found that the vertical jump and wingate test gave good predictions of on-ice acceleration. However, his results implied that anaerobic power does not help players maintain their speed and ability to produce force in repeated bouts, often seen in team sports. While this further confirms the importance of triphasic training in power dominant sports, it does raise the question of, is it more suitable for sports that require single bouts of effort, such as a throw athlete? The eccentric phase of training is vital for effective deceleration. It stresses muscle fibers and tendons with slow movement, and ultimately the athlete is unable to produce in terms of force what they can't absorb. During the eccentric phase of triphasic training, we see myosin forcefully ripped from the actin binding sites, resulting in micro damage. This leads to adaptation in the form of stronger attachments and stiffer tissue. The study looked at the effects of increased RFD as a result of fast or slow eccentric squats. Diaz models regularly highlights the importance of fast eccentric phase as a development for force absorption, which is a precursor for the athlete's ability to produce force during the concentric phase. During the study, 18 young novice lifters followed a 6-week program of either fast or slow velocity eccentric squats. For fast eccentrics performed at 70% of the max, while 90% was used for the slower group. Slow eccentric training was 20 to 30 repetitions per session and 3 to 4 second duration for each rep, while during 3 to 4 seconds duration for each rep, which was successfully used to increase muscle strength and hypertrophy. The pilot study returned data showing higher overall impulses in the slower group and noted that athletes were unable to tolerate loads greater than 70% while performing fast eccentrics, which is likely a result of the chosen athletes being young novice lifters. The study concluded that RFD and fascicle length increased significantly in the fast group, while muscle thickness increased only in the slow group. Significant correlations were found between training-induced changes in fascicle length and RFD. These results suggest that fast eccentric resistance training may be more appropriate for increase in rapid force production seen in power sports compared to slower eccentric resistance training. The triphasic model places a strong emphasis on the isometric phase, which is the brief transition phase that is commonly missed due to not being seen within the CALS V of muscle action. Following an eccentric phase, the athlete must learn how to harness and deliver force following a given movement. Studies suggest that increased muscle stiffness may in fact occur in large for the ability to employ co-contraction at specific portions of muscle movement. More importantly, research has demonstrated that the isometric position creates the greatest degree of co-contraction, which in turn increases muscle stiffness. all of which is previously described as improving torque, stabilization, proprioception, and movement vision, all key attributes that in turn contribute to improved RFD. Bimson conducted a study supporting other research, which was on reported improvements in RFD and proprioception following isometric training. However, the test was performed over a limited period of time, and thus the results reflect this. The focus was on the ending, the focus was predominantly on the end sporting performance rather than the attributes of the training. There was no conclusive results to the support. There was no conclusive results to support his findings, but this might be due to the reduced time the study took place for. This is further evidence to suggest that the triphasic training may have a great impact on single effort power-related sports, but not on the multiple bouts used in and seen in team sports. Similar to other programs, there is a limited direct research that follows the entire protocol set out by DS. However, what has been covered does clearly show significant improvement compared to the control studies. It's clear to see that by isolating focus into 3 phases of movement appears to result in greater RFD during later phases of a program. While the program requires a high level of coaching, the key development of RFD requires the athlete to always deliver with intention. While the program does deliver on what it sets out to do, a coach should be mindful to understand how the RFD will improve their athlete and the consequence that it has on their chosen sport or skill. Triphasic training clearly displays its strength with power athletes. However, this should not necessarily be regarded as the only option when looking to develop power sports. Thank you for taking the time to listen to my presentation.